We're going to look at various layout tools, and the topic is marking off and out. This applies to general engineering. The objectives of this document. Let me say first that this document was originally in the form of a multimedia presentation, but I converted it to a PDF file. Objective: to list the common tools used for layout work in the mechanical workshop, to explain the uses of the layout tools used in the mechanical workshop, and to draw the layout tools used in the mechanical workshop. Layout, laying out. It is a shop term which means to scribe lines, circles, centers, and so forth upon the surface of any material to serve as a guide in shaping the finished workpiece. We have the surface plate as one of the tools. A surface plate provides a true, smooth, plane surface. It is used in conjunction with the surface and height gauges as a level base on which the gauges and the workpiece are placed to obtain accurate measurements. These plates are made of semi-steel or granite and should never be used for any job that would scratch or nick the surface. So it is an example of a surface plate. The surface gauge. The gauge can be used to scribe layout lines at any given distance parallel to the work surface. So this is a surface gauge. You have the clamp, the scriber, the spindle here, spindle nut, the base, spindle rocker bracket, the rocker adjusting screw, and the gauge pins. So you can slide this along a corner or some surface, and the scriber would mark a line on the workpiece that you're going to be working on. The steel rule, which is really a ruler, is a simple measuring instrument consisting of a long thin metal strip with a marked scale of unit divisions. So it is really a rule made of steel. So you have the measurements here in millimeters: 50 millimeter, 100, 150, 200, 250, 300 millimeters. 300 millimeters is 1 foot. So this rule is a little more than 1 foot long. The scriber. A scriber is the layout tool that is used to produce lines. The point is made of hardened steel and is kept sharp by honing on an oil stone. That means you sharpen it using an oil stone. To obtain an accurate layout, fine lines must be scribed on the metal. So this is a scriber. The tip is very sharp, and you draw it along a straight edge on the metal, or it could be a curved edge on the metal to mark a line on the metal surface. The trisquare. A trisquare is used for marking, measuring, and checking the accuracy of right angles. It has a metal ruler set at right angles to another straight piece. A traditional trisquare has a broad base of steel or a brass riveted to a metal handle. So this is a trisquare. It's called a square because it's at 90 degrees. The corner here is at 90 degrees. The divider. When laying out circles, arcs, and radii, it is best to use the divider. The legs of the divider must be of the same length and kept sharp. The divider can also be used to transfer measurements. So we have the divider here. We turn the screw to adjust the distance between the points as the legs open and close. So this is the divider. The odd leg caliper. The hermaphrodite caliper or the odd leg caliper is a tool used to lay out lines that are parallel with the edges of the workpiece. It can also be used to locate the center of cylindrical shaped workpieces. So this is the odd leg caliper. Odd leg because one leg is straight and the other bent. The inside caliper. It is for gauging inside dimensions, the size of a cavity or hole, and then transferring it to a steel rule to get a measurement. The points of its leg curved outwards. So this is the inside caliper. So in this case, you might have a pipe. My lines aren't very straight here. And you want to measure the inside diameter of the pipe. So you place this inside and adjust the legs to widen until they just about touch the inside surfaces. Then you can place it on a ruler to get a measurement. So that is the inside caliper. Then we have the outside caliper. For gauging outside measurements or dimensions, the size of a shaft, for example, and then transferring it to a steel rule to get a measurement. The points of the legs curved inwards, the outside caliper. So you would adjust this and place it outside of the shaft. Adjust it so that you widen the legs so that the points can go around the shaft. Then you adjust it in the opposite direction to close onto the leg, onto the outside of the shaft, to just touch the surface of the outside of the shaft. Then you place it on a ruler to get the diameter of the outside of the shaft. So this is the outside caliper. So you see the inside caliper point outwards because you put it inside and adjust it out to touch the inside of the shaft. The outside caliper has the points turned in because you want to go in towards the surface of the shaft. And the punch. The center punch is used to mark location of centers of holes. The dot punch or the prick punch is used to permanently mark locations of layout lines. And the difference only in angles of the prick punch. Ground to an angle of 30 to 60 degrees, that's a prick punch. You have the center punch, the dot punch, and the prick punch. So the prick punch is grounded at 30 to 60 degrees and the center punch to 90 degrees. So you have the prick punch and then you have the center punch. So again, this is used to permanently mark the location of layout lines. Alright? The prick punch that has sharper angle, 30 or 60 degrees. The center punch is a wider angle. Alright, so those are the layout tool, the marking out tool that we have looked at. So please remember them. That's it for this video.